Okay, so now we'll build a control chart. This will be an R chart and an X bar chart. We start with the R chart, which is the range chart, and then we go to the X bar, which is the averages chart. Okay, so you had your assignment to count the toilet paper on the roll. And I chose one company that you analyzed because we had more responses for that. And the target was 200 sheets of toilet paper. And now I've got little abbreviations for your names on what you counted. Now, this is a sample size of 4, because we had 4 rolls of toilet paper. Now, I've entered the numbers that you came up with, and so now, here we go. It looks complicated, it's scary, but it ain't that bad. Okay, so what we need to do first is to add up these and get a total. In this case, it's 806 total sheets of paper, and the sample size is 4, so we divide it by 4 to get the average. This is our X bar. So we add 206, 195, 199, 206 equals 806 divided by 4 equals, we hope, 201.5. That's our X bar, that's our average. It's an average, right? It's 4 divided by totaled 4 equals our average. So we do this for each of the, we have 1, 2, 3, 4, 5 sets of data, sample sets, and we add up those averages. See, we total divided by 4, total divided by 4, total divided by 4, total divided by 4. We have the averages, then we get a total, and then we divide by 5 because there's 1, 2, 3, 4, 5 of them. And then we get the average of the averages, X bar, which is 195.55 in this case. So that was easy, right? Add, divide, X bar, 195.55. Not that bad, huh? Okay, now we need to get some information for our range chart. And in this case, we take the highest reading from the sample set, and we take the highest and subtract the lowest, which will give us the range. In this case, our highest was a tie. It was 206. And then our lowest, this was our high, and then our lowest was 195. So we have 206, the high, minus 195, the low, equals a range of 11. Now we look at the next one. Our highest number here is 200, and our lowest, that's our high, our lowest is 192. Where was our lowest? Okay, so we come over here and say, well, the highest count was 200, the lowest was 192, subtract that, and we get 8. Nothing complicated about that, right? So these are our R numbers, and we add those up. This is crazy right here. This is nuts. This last one really worries me right off the bat. The high was 207, and our low was 134. Oh, maybe we had a measurement problem. I'm not sure if I wrote the person back or not. Wrote some of you back, said check your numbers, and they went back and checked their numbers, and they were the same. So automatically I got it. Whoo, a range of 73. So we add these up, 1, 2, 3, 4, 5. We get a total of 106 divided by 5, because there's 5, and we get an R bar of 21.2. So, not so bad, right? Not so bad. Now, these are all, we're going to plot these, and we're going to plot these, but in order to figure out our control chart, we need the R bar, the X bar, and the R bar. So, we're going to build an R chart. What we need is a center line number, an upper control limit, and we need to find the lower control limit. In this case, our bar is the center line, 21.2. Now, these pesky little D4, D3, A2 down here on the X bar chart, those are so elusive, but I found them and I've emailed them to you. They should be on the sample email that I gave you. The chart where we find this is right here. It looks like that. If I didn't send it to you, I will. But here, I don't know if you can see this or not. We have a column for A2, D3, and D4. And it says right here the size of the sample. And we go down, our sample size is 4, so we need to use these numbers right here. They're probably even circled on your paper. So, for a sample size of 4, D4 is 2.282. And we multiply that times R bar. R bar is 21.2. So that's pretty simple. We have 2.282 times 21.2 equals 48.37. Our center line, as I said, was R bar, which is 21.2, goes right there. And D3 from the chart is a 0. So 0 times 21.2 equals 0. So now we have our control chart, upper and lower control limits. Our upper control limit is 48.37. Our center line, which is R bar, 21.2, and a big goose egg for the lower control limit. Now we need to plot our R's. Our first R is an 11, which should go about here. Our next R is an 8, which goes here. And then our next R is a 3, which goes here. Next one is an 11. And then, boom, we get a 73. Where the heck did the 73 come from? If there wasn't a measuring error, we've got a problem because it is way out of control. All of this should be fitting in here if our system is in control. But no, we got a 73 on the range. So, the R chart is out of control. We need to correct the problem and just start over. Start taking, imagine it's a toilet paper factory and you're the quality measurement person. So you just go out every hour or so, take your sample. Well, we need to start over, just start over. But in this case, with the video, that's difficult. Hopefully on the next, your next sample numbers, that won't happen. But if it does happen, the 73, the R chart's out of control. Stop, correct the problem, and start over. Okay, let's just pretend like the 73 isn't there. Now we'll go build an X bar chart. X bar chart. We need to find our center line is X bar, which we already have right there, which is 195.5. Now we need to find the upper control limit and the lower control limit. Here is the formula. X bar plus A2 times R bar. Now, the lower control limit is pretty much the same, except it has a minus sign. It's X bar minus A2 R bar. So, for all of these, we need our 195.5, 195.5, 195.5. This one is going to stay the same. We need to add A2 R bar to the top and subtract it from the bottom. So, when we go to our page and we look up a sample size of 4 and we find A2, we get the number of 0.729. We'll use it on the bottom and on the top. And we'll multiply both of them by 21.2. So when we do that, we get 195 plus 15.45, which is what that is. And here we have 195.5 minus 15.45. So now we're at the control chart now. Our center line, 195.5. It's been consistent, hasn't changed. That's what it is. It's there. And then our upper control limit should be 211. Our lower control limit is 180.1. So now we have the center line, the upper control limit, and the lower control limit. Now we need to plot the X bar. Let me put that on here. Plot X bar. So we go up here and we see a 201. It's in there. 196, 194, just under our target. 201 and a 183. So in this case, it was in control. So if only this one had been in control, then we go to this one. You can see the little instructions, it's numbered steps. Then we would be in control, but we're not because of that. So at the moment, let's just pretend like this is in control and we're here. All of this is in the control limits, so it's in control. Now, do we freak out when it goes to oh no, it's going down? Well, maybe it could have continued down, but it went back up and then it went way down. And that's a warning. It's getting close to the control limit, the lower control limit. So we might need to keep our eye on that. Now the assumption is all of these were taken in order. So there you go. Building 2 control charts, and there we go. So this is our big problem right here. We need to go investigate that. If that's a wrong number and it should have been like a 194, then it would have been in control. This would have been in control. This number probably would have been right there, and everything would be hunky-dory. Now, look at this, because, well, first of all, our target was 200, and here it's showing that our average of the averages is 195, which shows we're down a bit. Yeah, see, look, we're down, right on target, and way down. So that's what we're capable of. Look, you do not, according to the theory, you do not freak out until it breaks the 180 line or the 211 line. So even if it had gone up to 210, you go, wait, well, don't touch anything yet. Try it again. Oh, it went back down to, so it's all, this is what we can expect. And really, when you look at it, this is very forgiving. 180 to 211? That's forgiving. I mean, really, that's a lot of variation that would be expected with the current system. We could tighten this up. Just because you buy $1 million machine doesn't mean it's going to make everything better. It might complicate things to the point that everything's screwed up. But we could invest in some, maybe invest in some equipment, maybe train the employees, maybe get better materials to work with, and get this variation down to where it's more like that. So there we go. Now I'm going to put one up for you to try for homework.